Hello, my name is Colin, and welcome to part 22 of Let's Build a 2D Platformer in the Godot game engine. In this tutorial, not so many series, we're building this 2D platformer video game. In this game, of course, you control a little player on screen using keys on your keyboard. In this game, of course, you can walk and run and jump and fall and explore a large level. You can collect coins, jump on and squash enemies, get hurt by enemies and lose lives. You can climb ladders, shoot fireballs. That's the game that we're making in this tutorial series. If you want to go ahead and check out the rest of this tutorial series on how to create this game from start to finish, I'll go ahead and put a link up on the screen right now, and you can check out there all of my Godot 3 tutorials. In this video, we're going to be adding a couple of very neat things. We're going to be adding an on-screen lives hearts counter, so you can tell right when you're playing the game how many lives you have, and that means when you hit an enemy or fall off a cliff, you don't automatically just die and go to the game over screen. You lose a life, you start the level again, or you jump back and you lose one of those hearts on your screen. And one of the neat things we're going to be doing in this video is making lives persistent across levels. That means that we're going to be making what's called a singleton in programming, which is a code file that persists your lives or anything in that file across all your game levels. So when you go from level 1 to level 2, if you have more levels in your game, it will remember how many lives you have from the previous level, if that's what you want. Let's go ahead and jump in. The first thing I'm going to do here is I'm going to take a look at my heads-up display that I already have in my game. If you've not seen a video in which I made a coin counter on screen to keep track of how many coins I have as you play the game, I'll go ahead and put a link to that video up on the screen right now. Just to remind you, if you want an element in your game to not follow along with the world, in other words, you have a heads-up display on your screen that essentially sticks to the glass of your monitor and your camera moves with it. In other words, if I press play scene and I play my game and I move around my game level, well, that heads-up display up in the top left corner is sticking to the glass or the window of my game and not following the level background as it moves past where I can see, okay? To do that in Godot, you need to add what's called a canvas layer node, and that's what this HUD node is. So if you don't have that yet, you'll want to select the root node of your scene, press plus, and search for canvas layer. And it's that one right there. As soon as you add that node, any other child nodes, in other words, this panel, this darkened area here, and all of the textures and labels that have text in this area are a child of that node, and therefore they move along with that HUD and they don't follow the world as it's passing by when you move around your scene with the game player. So in this video, we're going to be adding hearts into this HUD. Let's go ahead and get those heart sprites and put them in our project folder. On my desktop, they are right here, and I'll be giving you a download link so you can go ahead and download both of these files zipped in the description area below this video here on YouTube. So they look like this little heart with a transparent background around it and an empty heart. Okay, you can go ahead and download those in the description area below this video here on YouTube. Once you unzip that file with these two pictures, you can select them, right click on them and copy them, and then go into your project folder where you hopefully have a folder that's at least somewhat organized with all of your game assets. Here I have my assets folder with all of my game sprites, all of my fonts, all of my sound files and music files for my game. They're all in here. I have a folder here called HUD for heads up display, where I have that coin from my HUD. I'll go ahead and paste these hearts right there. And now if I go back into the Godot game editor, right down here, you can see in my file system doc, because Godot automatically imports any sprites or compatible files that you put in your project folder, you can see here in my HUD folder, there they are. My HUD is too small, and I think the elements right now in it are too big, because right now if I just make my HUD bigger, it'll take up too much room. So very quickly, I'm going to select these elements and scale them down. I'll hold shift on my keyboard to make that a little bit smaller. This and this, these two elements are both labels which have a font and text. To make the font smaller, I can just select that element and go over to my inspector, where there is a rather new section in the inspector called theme overrides. This used to be different. You used to change your font size somewhere else in the editor, and some of you might have found that as you were following along with this video series if you were using a newer version than I was at that time. But if you open up the theme overrides section right there, there will be a fonts section. If you open up the fonts section, you'll see a dynamic font, and you can open that up where you'll see your font size. I'm going to change this to 25 and press enter, and then I'll move it over right there. This one, I'm going to make it smaller as well. So again, in that same theme override section, in the same font section, I'll open up my dynamic font and change it to about 50 or so. Okay, and I'll move that element up. I can make it shorter if I want to, like that, and I'll make it less wide. And this panel, therefore, I can just grab it and make it a little bit wider and a little bit shorter. There we go. To add hearts into our heads-up display, I'm going to be selecting my canvas layer HUD node. I'll press plus. We'll be using what's called a texture rectangle. Okay, so if I search for texture, it's one of those green control user interface nodes. We could be using a sprite for this, but I'll show you why we're going to use texture rectangle. It's a different node that does a slightly different job. So there it is right there. I'm going to go ahead and name it Hearts Full. And this name does matter. You want to name it something that you know. Hearts Full with a capital. In fact, I'll make it have a capital H as well. I'm going to go ahead and drag my Hearts Full PNG picture into the texture empty slot of that texture. And there it is. I can go ahead and put it in my heads-up display. If I make the heart bigger or smaller, that is not how this texture rectangle node works. If you want it to stretch or scale, you have to turn on that texture rectangle's expand property over in the inspector. If you turn that on and you stretch out the heart, that's how you do it. Except we're not going to use this expand property to scale the heart. Instead, we're going to change our stretch mode here from scale on expand to tile. And when you do that, you can have it tile in that bounding box rectangle of this node, and therefore you can control how many hearts you see. And that's exactly how we're going to make multiple hearts and control how many hearts you can see on the screen. Just a note that this texture that I gave you, the hearts picture, if I go down to the rect property of this node, has a size. The actual picture file that I gave you has a size of 45 pixels tall. That's good to know. And a width for one heart of 53 pixels. Okay, so that's exactly how big it is. Now, if you want these hearts to be bigger or smaller on your screen, obviously now you can't drag this little handle. What do? Well, you change the scale down here. So I'm actually going to change the scale to 0.8 and 0.8 to make it a little bit smaller on my screen. But when I do that, you should know that the size does not change. Therefore, 106, which is 2 times 53. In fact, I can just type 53 times 3 if I want 3 hearts, and that'll change it to 159. I don't have to do the math there for myself. You can see I have 3 hearts now, and we're going to control this with programming to make it the right size for the number of lives that we have. Okay, we have the right number of hearts. I'll put them in the exact right spot, but I'm going to duplicate that node. So I'll right click on it and say duplicate, because this will be my hearts empty. So I'll type empty here and change its name, and I'll go ahead and drag my hearts empty sprite over into its texture like that. So they're in the exact same spot, and I'll make my HUD a little bit smaller with its panel. Just so you are aware, you might notice this, that the sprite does not look perfect in the editor. You'll see a little bit of extra tiling at the bottom. Don't worry, that should not show up in your game. I haven't had that problem yet. Okay. But we have hearts in our HUD now, and if I go ahead and press play scene to play my game, you can see they're on the screen, but I have my empty hearts over top of my full hearts, and of course they have no relation to how many lives I actually have, because I need to program that in my game. To make lives that persist across levels, we need to make what's called a singleton. A singleton is a code file that's not associated with any object in your game, like a code file that's on your character or enemy or coin. This code file is going to be just in your project folder, and then we're going to tell your project to load it when your game starts. And we can access that code file, including any variables or functions in it, using a keyword a name that we give that code file. So to do this, I'm going to go ahead over to my file system doc, and I'll right click on my res folder right here and say new script. The script is going to be called global.gd, just one .gd, and I'll leave everything else here the same. It's a GD script file, of course. I'll press create. When you create a new code file just over here in the file system doc, it does not load it into the script workspace yet. You have to actually go and find it. So I'll scroll down and go into that global.gd. There it is. I'll double click to open it up. In this file, I need to keep, I believe, this extends node line. I'm not actually sure about that, but I'll leave it and I'll delete everything else. These are all just comments and a ready function that I don't need right now. And I'm going to give my game a lives variable. So var lives, and I'm going to have 3 lives in my game. So I'll type equals 3. But I think I'm going to do this a little bit differently, and this is going to help us out later in this project, in this video. I'm going to actually make another variable before lives called var max underscore lives, like that, and I'll type equals 3, and then I'll say lives equals max underscore lives. Why am I doing this? Because maybe later in the future, you'll want to have a heart object that your player can pick up. And when they do that, that will increase the max number of lives in your game. And therefore you might have more hearts available to you to fill up so you can live longer in your game. Also, this will come in handy for determining how many empty hearts we should have a little bit later. Okay. Now to make this singleton file auto-loaded into our game. In other words, when we play our game, we want this to be a thing that we can refer to with the word global, so we can access these lives and manipulate them when you touch an enemy and lose a life. We need to go up to our project settings, so project menu, project settings, and go to this auto-load tab at the top. This is where we can auto-load in a resource in our game, in particular a code file. So I'm going to pick the path of that code file. I'll just press this little folder icon and choose in my project folder global.gd and press open. When I do that, it recognizes the file name and it suggests a node name for me. That means a keyword that I can use in my program to access the code file and anything in it. So it suggested global to me with a capital G. That's okay. I'll press add, and there we go. It's really that easy. Now in my game, I can access anything in this global file by saying global dot and then whatever that thing is in the code file, like global.lives. We'll do that in just a few moments. However, right now we want the HUD, the heads-up display in our game, to display how many lives accurately we have right when the game first loads. So if you don't have a code file on your HUD node, like I do, if I go ahead and click on that little icon, it brings up the code file. And you can see here, I already have code to make my coin counter work. And by the way, I could make my variable coins in that global file. If I want to keep track of how many coins I have across multiple levels, it's really pretty easy to do. And you'll see that by the end of this video. In this file, I'm going to go ahead and make a function called func load underscore hearts. And what this is going to do is it's going to basically use that global lives to determine exactly what hearts should be in the HUD. And whenever you lose a life in your game, you're also going to be calling this load hearts function to reset or update the number of hearts in the HUD. So what we're going to be doing here is saying $sign. This is how we access children nodes of the HUD node. I want to go from my HUD node's code and say, hey, change the width of that node in the HUD of the hearts, change the rectangle width to equal the width that corresponds with the number of lives that I have. So in my script file, I'm going to say $sign to access the hearts full. So $sign hearts full dot, and then I can access the rectangle width by saying rect underscore size. So it's down below rect scale. It's rect underscore size dot x. And then I can say equal global. This is where I can access that code file, global dot lives. However, if you just had this code, what it would do is make the rectangle of your hearts full 3 pixels wide. We don't want that. We want to make the rectangle size 3 times, well, 53. That's the number of pixels that that picture is wide. So I'm going to say times 53, and I'll just recall that number whenever I need to access it. Okay, I'll just type that in as a literal number, which is not the best coding we can do, but we'll just do it that way to keep it simple. On the next line, I'm going to access the empty hearts and make them the correct width as well. So I'm going to say $hearts empty dot rect size. So I'll go all the way down with my arrow key, rect size dot x. We're not going to worry about dot y. It's already the right height, so we'll just leave that alone. Is going to equal, and this is where I have to do a little bit of very simple primary school math here. I'm going to take the number of lives that we have and subtract that from the max lives. So if we have 2 lives and the max lives is 3, I want to say what's 3 minus 2? So you have 1 life left over, and make the rect size dot x of the hearts empty equal to that 1 remaining left over. So to do that, I'm going to actually put some parentheses here. Don't forget that, it is important. And we're going to say global dot max underscore lives minus global dot lives, like that. So if max lives is 3 and global.lives is 2, that'll be 1 left over, and we need to multiply that outside of the parentheses times 53. Got it? Okay, one last step. If we had the code just like this, what it would do is it would put the empty heart at the first location and the full hearts also at the first location, but extending out to 2, so you wouldn't have the empty heart over here. I need to shuffle over the empty heart's position on the x-axis over to here, depending on how many full hearts there are. So in my script file, the last line in this function is going to be $hearts empty dot rect underscore position. So I'm going to actually change the position of it with code. Dot x is going to equal, and this is where I have to do a little bit of primary school math again. Just addition though, for the most part here, I'm going to say $hearts full. I want to move it over by the width of hearts full. So hearts full dot rect underscore size dot x. Actually, this needs to be rect position. We're going to put it at the position of hearts full, but then shift it over. So there we go. And then we're going to add to that the rect size of hearts full. So I'm going to be a little bit lazy here. I'm going to copy that section of code. I'm going to paste it right there. So we're taking the rectangle position of hearts full and adding to it the size of hearts full. So rect size dot x, that x is still there at the end, except if we change the scale of that picture, which I did to 0.8 a little while ago, I need to multiply the rect size times that. So I'm going to say at the end here, times $hearts full dot rect scale dot x. So that's a little bit of a line of code there. I'll go ahead and maximize my workspace. And can you see it all there? Yes, you can. I'll minimize my output dock at the bottom. So we're making the position of the hearts empty object in our HUD equal to the position of the hearts full, but we're shifting it over by the width of hearts full, which we have to take into consideration the scale of hearts full as well, which is 0.8, but we can access it using this variable, of course. This function is done, but we have to call it every time we lose a life and when you first start your game. That's going to happen using this ready function. This ready function is on my HUD. I'm already using it. If you don't have it, you can go ahead and type it out. In that function, we need to call load underscore hearts, just like that. It should work. Let's go ahead and press Control S to save. With level 1 selected, I'll go ahead and press play scene. And as you can see, I have 3 lives and no empty hearts. That node, that texture rectangle, got a width of 0, and the width of the hearts is equal to 3 times 53 times 0.8 scale. So it's all good. It works. But when we lose a life, or when we hit an enemy, we still go to the game over screen. So let's go ahead and make the lives actually work. Just to remind you, in my game, if I go back to my 2D workspace and take a look at an enemy, if I go into one of my enemy scenes, so I'll click on this little icon here, my enemy has a sides checker. And this is an area 2D that's built into the enemy. If you come into contact, if your player comes into contact with this size checker, right now you die. And that happens if I go into the enemy's code. In fact, if I select that sides checker and go over to my signals under the node tab, you can see that on my enemy, body entered, this signal, this event calls an onsides body entered function. If I go ahead and double click on that, it takes me to my enemy code where I have an onsides checker body entered function. And if the object that entered the size checker is on the right layer, it calls on that colliding body, which is my character, an ouch function. So if I go back to my game and back to my level 1 scene and select my character and go into my character Steve's code, you can see if I maximize my workspace, and I'll scroll over to the side there, I can find that function on Steve called ouch, which is all the way down here on my line 176 of code. Right now, if you get hit by an enemy, of course, it calls this ouch function, which makes you red and transparent using set modulate. It makes your character jump either to the left or right as well. It releases you pressing left or right on your keyboard, and it begins a timer that's built into your character. What that does is it makes sure that after a few moments where you can see your player turn red, the timer runs out and it calls this function on timer timeout, which makes you go to the game over screen because you just lost. We don't want that to happen. So I'm going to go ahead and delete this line of code. Instead of losing the game when you hit an enemy, we're just going to have the timer run. And then after that timer runs out, we're going to use the set modulate function again. I'll go ahead and copy it. And when the timer runs out, we're going to reset your color to no longer be red and no longer be transparent. So when we use the set modulate method and give it a color, we can simply reset the red, green, blue, and alpha, that means transparent channels, all back to 1 and 1 and 1. And that'll make us the normal color that we should be. I might also go ahead and select that timer in my Steve scene. So I'll go into Steve's scene because I think the timer right now is set to 0.7 seconds, which is not very long to see your character turn red and get hurt. So I'm going to select that timer and go over to the wait time and change to something like 2.5 seconds. And by the way, this is a one-shot timer, so it only happens once. It doesn't repeat every 0.7 or now 2.5 seconds. There we go. But none of that actually makes you lose a life. So in my Steve code, when we call that ouch function, we also need to lose a life. So I'm going to go back to my script workspace and back to Steve's code and back to that ouch function. And right away, I could say global dot lives minus equals 1. Minus equals takes the number on the right of that operator and subtracts it from the variable or value that you have on the left. It's a lot like saying global.lives equals global.lives minus 1. It's a shorter way of doing that. However, because we lose lives both when we hit an enemy and we call the ouch function, and we lose lives when you fall into a fall zone, we're not going to do this right here. Instead, I'm going to make a function on global, and I'll call it right now, called global.lose_life. And that will be used for both enemies and the fall zone. We don't have that right now, so I'm going to go ahead and jump over back to my global.script file. If you didn't get that, there it is. You can pause the video right there. But in my global script file, I'm going to make a function called func_lose_life. Like that. What do we have to do here? Well, I have to say lives minus equals 1. And because we're already in the global file, we don't have to say global.lives minus equals 1. We can just say lives. Okay? That's wonderful, but when you lose a life, how do you actually make that display on your heads-up display? Right now, I can have a variable called lives, and I can lose a life when I hit an enemy, but that doesn't actually make it show up in my game, in my heads-up display, and update the number of hearts. So right now, we could do this in a couple of ways. We could set up an elaborate system of custom signals in Godot, which we could have communicate an interaction between your enemy and your player and send a signal to your HUD to then update the number of hearts by simply calling the HUD function, which is called load hearts, to update the number of hearts in the heads-up display. I don't like that. That's more complicated than what we need to do. Instead, I'm going to make a variable in our global script file called var. So I'll go back to my global script file and type var HUD. This variable is going to act as a pointer to the HUD that's in your current level. So if you ever need to access your HUD from any object in your game, like between your enemy and your player, when that interaction happens, we can simply say global.HUD. But how do we get this variable to act like a pointer to the actual HUD in your game? Well, if I go to my HUD script and I go to this ready function, I can simply say in the ready function, global.HUD equals self. And what this will do is, because you're passing basically a reference to the HUD itself to global.HUD, whenever you refer to global.HUD, it'll simply go, no, you're talking about the real HUD in your game, and you have a reference variable. That's something that you can do in programming. So now that we have that reference, we've made our HUD at the beginning of the game give a reference to itself to the global script file, which will be right here. When we lose a life, we can subtract one life from our lives variable, and then we can say HUD dot, and now we actually have to know the name of that function because it's not going to know what functions I've written in my HUD script. So if I go back to my HUD script, the function is called load hearts. So I'll go ahead and copy that name like that and go back to my global script and say HUD dot load hearts, and that should work. Let's go ahead and press Control S to save all our script files. And then with my level 1 tab selected, I'll go ahead and press play scene. And so now I have 3 lives. If I hit an enemy, aha, I lose a life. It works. If I hit another enemy again, I lose another life. But what happens if I lose a 3rd life? I've lost all my hearts. At this exact point, I should be sent to the game over screen. So I'm going to go ahead and close my game. And in my global file in lose lives, I'm going to say, after I reload the hearts, the game is immediately going to switch over to the game over screen. And that code is simply get_tree dot change scene. You've seen this many times before. This is how you change a scene in your game. You get the project, which is get tree. You change the scene and you have to pass it a string, a name of the path of the file that you want to get to. So we're going to find our game over screen in our file system doc, which is right here, and copy its path starting with res:// I'll copy that, Control C, and in the function argument or parameters, I will type double quotes and paste res/game over. So if I go ahead and save that and select level 1, I'll go ahead and try this out. I'll press play scene. And now if I lose lives, that wasn't supposed to happen. What happened? We put a command that says when we lose a life, automatically go to the game over screen. What are we forgetting here? Well, we want to check to see if our lives is now less than or equal to 0, because there could be some circumstance where maybe you hit 2 enemies at the same time and lives goes down to -1. So here I'm going to say if lives is less than or equal to, that's how you type that, 0, well, we need to go to the game over screen. So I'm going to select this line and press tab to indent it so it works properly. There we have it. Let's go ahead and press Control S to save. If you need to pause the video to get that, please do. But I'm going to select my level 1 tab, press play scene. And so now if I hit an enemy, I lose a life. If I go ahead and touch another enemy, by the way, do you notice that my character turns back to its normal color after 2.5 seconds? Hopefully you notice that. If I go ahead and touch another enemy and then touch another enemy again, it is now game over and my lives work. But what about the fall zone? What happens if I fall off a cliff? Well, right now, if I go ahead and jump over off a cliff, it's simply game over, and that's not what I want. To fix that, if I go back to my level 1 scene and take a little look around, my fall zone is an area 2D down below my game platforms. It spans all the way across my entire level where I can fall down and possibly enter that zone. This fall zone is an area 2D, and it has a signal. I'll go ahead and bring up my node dock over here with my signals. And this signal, when a body enters the fall zone, it calls a function on Steve. Now, that's not ideal. Ideally, we would have another object handling the fall zone interaction. But right now, if I double click on this signal handling function, it'll jump me over into Steve's code, where I have a function here on my line 169 called on fall zone body entered. And if that interaction happens, we are going to the game over screen. Obviously now, we don't want to do that, so I'll delete that one line of code, and I'm going to say global.loseLife. It's almost as simple as that. Lose life, if I go ahead and press Control S to save. If you want to pause the video now to get that line of code, please do. But if I go back to my global file, it will subtract a life, it'll reload the hearts, and if lives is less than or equal to 0, it will load the game over screen. However, if you hit the fall zone and you don't have 0 lives, what happens? What happens if you had 3 lives and you hit the fall zone and it loses a life and it shows up on the hearts? We don't want your character to keep falling. So right now, the easiest thing to do without having a respawning system in our game is simply on our Steve in that on fall zone body entered function is we're simply going to reload the current scene in our game to restart the level, but it'll again maintain your lives because lives persist across levels. So I'm going to say here, get underscore tree dot. And now we're not going to use change scene because if you hit the fall zone, it could be on different levels. So I'm going to say instead, reload current scene. That's a function that's built into getTree. It's a method actually because it's built into a class called getTree. It's a method called reload current scene that basically does what it says. It reloads whatever scene that you're currently in. There's one problem with this though. If you enter the fall zone and you lose a life, and you are now down to 0 lives, you should go to the game over screen. Now, technically, the global lose life function has that in it. It says, if I go back to my global file, if lives are less than or equal to 0, go to the game over screen. But it turns out, and you would think that in your Steve in this function, that it would run all of the code in this function first, and it would send you to the game over screen if your lives are now less than or equal to 0. And if it did that, it wouldn't run this line of code. That's not quite how it works. I'm not exactly sure why. I'm not sure if they have like multi-threading going on here where it doesn't wait to finish all the code in this global function, lose life function, before it tries this. But it turns out this line of code will not work unless you say on the next line, if, because we want to only reload the current scene if lives is not 0. In other words, if you still have at least 1 life left. So I'm going to say if global, pardon me, global with the lowercase l, global dot lives is greater than or equal to 1. If that's the case, I'll put a colon at the end of that line and I'll tab in the next line so it works. If your lives are greater than or equal to 1, well, you haven't gone to the game over screen, but you do want to reload the current scene. So I'll go and press Control S. If you need to pause the video, please do. But with level 1 selected, I'll press play scene. So now if I hit an enemy, I lose a life. In fact, I've now lost a couple of lives. Right now, if I go ahead to my cliff, I've lost the game. However, I'll go ahead and play this project again. I didn't just press the play button there. I hope you noticed that. If I go ahead and lose a life, and then see my heart has been subtracted there. If I go ahead then and jump off a cliff, it simply reloads my level, but my lives persist. That's what I want. But we have a problem. Because these lives persist across levels, if I lose the game, if I hit an enemy and lose all my lives, I go to the game over screen. And this is a menu, so I can press the main menu button again to go back to my menu screen. And then if I press play again, well, I'm now put back in my game with no lives because that's the case. It's a persistent file and persistent variables across all my different game screens. So what I'm going to do is go back to my game menu. If you have a game menu like me, you can find it in your file system doc. It's a scene file. Mine is called titlemenu.tscn. If I go into that scene, I have a play button, and that play button has a script file. If I go ahead and take a look at that script file, it's very simple. It's connected to a signal. So when you click on the button, it runs this function called onPlayButtonPressed. It goes to our level 1 scene. That's wonderful. Before it does, I need to reset global.lives back to max lives if that's what I want. So I'm going to say here global.lives is going to equal, and you could put a number in here, or like me, you could say max_lives, and it needs to be global.maxlives, just like that. Okay, so now if I play my game, I'll save this code file. If you want to pause the video to catch up, if you need to, please do. But I'll go back to my level 1 scene, press play scene. I'll go ahead and very quickly lose a life, and then I will fall off the edge, and then I will lose one more life. I go to the game over screen. If I go back to my menu and press play, I now start with 3 lives again, and the game works as it should, like that. Now, that is going to be it for this video. I recognize at the end of this video, we have working lives and working hearts. And when you touch an enemy, you lose a life, or when you fall off a cliff, you lose a life, and it reloads your current scene. What I would like to do in one of the future videos, so we still have a few little outstanding issues or things that could be a little bit better, if I go ahead and press play scene, while I am playing my game right now, if I hit an enemy, so I'll go ahead and get hit by an enemy and jump back, while I am still red, I can get hurt again. And I don't like that. So I want to add that in a future video, handling the collisions between your character and the enemy when you're hurt. You should be a little bit invincible for a few moments to let you get away from your enemies. I also want to add blinking red to your character so that when you get hurt, you don't just turn red solid for 2.5 seconds, you blink. And I want to stop us from being able to collect coins and stop us from shooting fireballs when we're hurt as well. That'll be in a future video, hopefully. But that'll be it for this video. Thanks so much for watching. If you made it to this point in the video and you followed along and created your own heart counter on your screen and lives. As always, my name is Colin, and you can find out more about this channel and what I'm working on next at my Facebook page and on my Instagram page. In those 2 places, I post sneak peeks and previews of what I'm working on next in this channel. Also, if you haven't already, please go ahead and click on that like button below this video. It really helps out me and my channel and gets these videos more seen. And of course, if you like this video or if you learned something, please go ahead and click on that subscribe and that bell icon as well, so you see more videos if you like this video and you want to learn more. But that'll be it for this one. Thanks for watching. I'll see you in the next one. Bye-bye.